All right. So sorry, I forgot to mention that I stopped recording. I didn't start recording yet, but for the exam redo, it's due next Monday. Please make sure that it is only you and online resources that do not have a solving aspect to it, or in like you can look at your notes, you can look at other textbooks, you can look at resources online, but nothing like Wolfram Alpha, nothing like that, because the whole goal, remember, of this thing is for you to figure out your mistakes, to retry the problem. Other thing, because this got asked and I forgot to send it out in email. You do not need you do need to do the whole problem over again. Even if you did it, like even if it was like a minor thing, I want you to do the whole problem over again. Just because it's easier for me to grade it that way. And feel like, I mean, and it might be frustrating, but remember, if you got it mostly right, then it's just basically copying and then fixing the little tweaks that here or there. You do not need to do the whole exam over again, just the problem that you want to be regraded. So if you got 100% on a problem, don't bother. If you don't know how to do a problem, and like you don't have to do it, it's not required to turn the redo with every problem that you got points marked off on. Paul.
I checked the blank exam copy on Monday. It wasn't there.
It should be on the front page, on the home page.
Thank you.
Yeah. On Monday, so it took me until Monday after class, towards the end of towards the end of the day. So it should be up there, but if it's not, let me know. And I will work on fixing that. It could, like, every once in a while, Canvas can be weird. So yeah. So that's what we're supposed to do. So like, and I didn't say this during the recording, just so for people who missed it. So yeah, only you on the exam. So no tutoring centers. I usually encourage you to go to tutoring centers, absolutely. But the main goal is I want you to do this with your own brain. That is the best way to learn this stuff. The whole goal of the redo is to have you learn from your mistakes. I can tell you with absolute certainty, being as a math major, there have been many times that I have been beaten down by mathematics and have to rise from the ashes. Hence why my son's name is Phoenix. I'm kidding, actually. Just I like the name Phoenix. But point being is there were many times where I did not know how to do something and failed, but I learned from my failure. And I would look back over I would look at solutions, or I would go to my teacher for help on what I did wrong. And that's where I learned the best. It wasn't the studying beforehand. It wasn't the studying during. It was the studying on the things that I messed up on that really stick. Of course, the things that you learn while you're actually studying and stuff do stick, but failure is a very good motivating tool and also a very good learning tool. That's why I have the redo, because it's always the case that sometimes you just don't see a problem right off the bat. Sometimes it comes to you 10 days afterwards, and encouraging that behavior will make you learn the math better. So anyways, let's go ahead and get back into the chain rule. So let's scroll. Where were we? Oh. 2.4. Where is it now? There we go. Okay, cool. So there is the Leibniz notation, and then there is the composition method. Both are fairly valid. However you want to do it. I find that most people like the composition method more. And what I can tell you is, just like with the product and the quotient rule, just like with those two things, it honestly, in my experience, it's one of those things that gets easier the more you do it. And that's true with basically anything, right? But what I mean by that, in fact, is that not only does it get easier, but it does get faster. As long as you're willing to kind of keep all the things in your head, it can become a lot faster to do it by once you don't have to write the F, the baby G. If you're able to skip that step, things go a lot smoother. It's important to start it out that way. That's how I started. That's how basically every mathematician starts in calculus. It's identifying the baby F, identifying the baby G, finding the baby F prime, baby G prime, and so on and so forth. But as they get better at it, they stop needing to do that so much. And if that doesn't happen to you, that's okay. I have plenty of colleagues who still do it that way too. But what I can tell you from experience is that it goes much faster, and less mistakes, the less you have to write, right? The more you write, the more chances there are for you to misread a plus sign or a minus sign, and so on and so forth. Anyways, so this problem, find K prime of X which is equal to x cubed plus x minus 3 to the third. Now you could FOIL this out and have a grand old time, but it would be better to use the chain rule. So if you're going to use Leibniz's notation, then using it, you're going to let y equal your outer function in terms of u. What is the outer function? In fact, it's better to like, I always mess that up every single time I teach this. It's better to find the inner function first. What is the inner function in K? X squared plus x minus 1. Very, very good, Gage. So u will equal x squared plus x minus 1. Now, the outer function is the thing that it's being raised to. The outer function would be x cubed or u cubed, because we're going to make y in terms of u. So then dy dx will equal dy du times du dx. The derivative of y with respect to u is 3u squared. And this also came up just so we're clear on what Leibniz's notation means. So dy dx, that is the derivative of y with respect to x. So dy du is taking the derivative of y with respect to u. If I had written dy dv, there are no v's. So in that context, v would be constant, or u would be constant, and you wouldn't have to ignore it. We just ignore it. But that's what the dy dx means. So it's the derivative of y with respect to x. Dy du, the derivative of y with respect to u. And then du dx, taking the derivative of this with respect to x, would be 2x plus 1, right? Now, the fact is, though, we want our formula, we want our derivative to be in terms of x only. But we know what u is. You are sitting in class right now. No. Thank you. Thank you. I will be here today, and that's it. I'll see you guys next week. All right. So you're just going to replace u with what you claimed it to be. Do you guys remember how to do those? Do you guys remember those things, the quadratics in disguise? Like x to the fourth minus x squared minus 6, where you had to make u equal to x squared. Is that? No, not a big deal. Don't ignore it. I'm being stupid. Is it the Pop Goes the Weasel song?
Negative boy decided to go to a house party. That square boy missed out on 4 awesome chicks, and it was all over by 2 a.m.
That's cute.
That is really cool.
I do like that.
I think so.
Thank you. I'm going to have to ask you about that again during the end of the class. So 3 times x squared plus x minus 1 squared times 2x plus 1. That is k prime of x. The composition method is very, very similar. It just, instead of using y's and u's, you use f's and g's. So you identify your inside function and your outside function. So your outside is f of x, and that's going to be x cubed. Your inside is what we already claimed. So g of x is going to be x squared plus x minus 1. So f prime of x would be 3x squared. Oh, you can't see? Sorry. Let me zoom in on that. We'll move. Is that better? Thank you. But we don't want f prime of x. If you go back up, don't worry, I'm coming right back to it. But the derivative of the chain rule is f prime of g of x. So you're going to plug g of x into f prime. So instead of 3x squared, it's going to be, so f of g of x, f prime of g of x, that is going to equal 3 times what, like we're going to replace the x with g of x. So it's going to be x squared plus x minus 1 squared. And then g prime of x, we already found it before, but just so we're clear, so 2x plus 1. So k prime of x is going to equal f prime of g times g prime. F prime, like the derivative of the outside times the derivative of the inside. So 3 times x squared plus x minus 1 squared times 2x plus 1. The same thing, which we should get, right? We should get the same thing. If we didn't, that would be a problem. Now here's a little, no, never mind. Stupid thing. Ignore it.
Now I want to hear it.
Just basically saying you can redo a lot of the questions from section 2.2. And if you like, you now using the power rule and the product rule, and sometimes even the chain rule, and you'll get a different answer, but it's the same thing. It's just in a different format. So don't worry if you try it using that and you get a different answer. It's the same thing, just written differently. So let's go ahead. Which way would you guys like us to do it more? Leibniz's or composition? I'm always curious about this. Leibniz, composition. Okay.
I like composition.
Well, we'll just I'm seeing like this is cool. That's actually the first time it's been like last 5 times I taught it, like most people like the composition method, but this time we're split 50-50. So we'll do it half. Well, sometimes we'll do the Leibniz's, sometimes we'll do the composition. I'd encourage you to try it the opposite way as well, just so you're comfortable. So this one right here. Find p prime of x, find the following derivatives. P of x is the 4th root of 2 minus 9x. First thing, right off the bat, I don't like dealing with radicals, so I'm going to convert this to exponential form. This is 2 minus 9x to the 1/4. So what's the inner function? 2 minus 9x. So let's use Leibniz's, and then we'll just keep back and forth. So your inner function, u, is going to be 2 minus 9x. And your outer function is going to be u to the 1/4. Because that's the outer function. That's the thing that the inner function is being raised to. The more and more you practice this, by the way, the better you get at it, of identifying the inner and the outer functions. So,
Which function are we using this one?
which method?
Which method?
Leibniz's.
Okay.
Yeah. So dy dx would equal dy du times du dx. Yes.
Examples, we need to write that out.
No, you can just go straight to it.
Okay.
Honestly, I'd encourage you to do to skip this.
Okay.
But this is just since we're learning it for the first time.
So U is always the inside and Y is always the outside.
Yes. So dy du would be 1/4 u to the negative 3/4. And then the derivative of u with respect to x would be -9. But we want this to be purely in terms of x. So p prime of x is equal to 1/4 times 2 minus 9x. That's what u is. To the negative 3/4 times -9. Or preferably -9/4 times 2 minus 9x to the negative 3/4. Either way is fine with me. I'm not picky. I mean, sometimes I am, but in that aspect, commutativity of multiplication doesn't matter to me. Okay. So not only, so part B is supposed to tell us something. All the rules can be combined. Product rule, chain rule, quotient rule, power rule, all these things can be combined and moved around. Sometimes you can have a product involving a quotient rule. Sometimes you have a quotient involving a product rule, so on and so forth. So this one is going to be a product rule from the get-go. So we'll make this our baby F and this our baby G. So baby F, oh, wrong color. Baby F is z to the 5th. So F prime is 5z to the 4th. And this time we're going to use the composition method. We're going to use Newton's way for G, because G is a composition. G of x is 1 minus 3z to the 2/3. So your outer, which we can call baby F, is what is the outer function? To the 2/3. It's the 2/3 portion. So you're Gage, remember we're doing this is our G. So this is our like our outer function is the power it's being raised to. So x to the 2/3. So f prime, well baby f prime would be 2/3 x to the negative 1/3. So f prime of G would be, let me zoom in a little bit, would be 2/3 times 1 minus 3z to the 2/3. And then G, baby G, the inner function. The inner function is 1 minus 3z. So G prime would be -3. Baby G prime. So this was all to find G prime, blue G prime. I probably should have changed that color. And make it blue. What am I doing with G of an X? Oh my God.
I was so confused.
Yeah. Okay. All right.
Do this, we believe in you.
Thank you. Z, that should be a Z. That's not G of Z. G of
P times 1 times 3z.
So it'd be 2/3 times 1 minus 3z to the negative 1/3. Oh my God. Okay, guys, we're just going to take a deep breath. Yeah, that's fair. Yeah.
Have me in the first half, not in the last.
So the inner is G.
Yeah.
1 minus 3z.
This is, yeah, that's 1 minus 3z, and it should be to the negative 1/3. I don't know why I wrote 2/3 again. Yeah. I'm very distracted, guys. Sorry. All right. So that's not the actual answer for G prime of Z. We're still we're finishing it. So it's the derivative of the outside. So 2/3. Evaluate the inside, but it's the negative 1/3. And then times the derivative of the inside, which would be -3. Or preferably -2 times 1 minus 3z to the negative 1/3. Okay. So now we're going back to the original problem, which was doing a product rule. That's what we did in blue and the red. Finding f, f prime, g, and g prime. So, using that information, capital F prime of z is f prime. So 5z to the 4th times g, 1 minus 3z to the 2/3. Plus g prime, which is -2 times 1 minus 3z to the negative 1/3 times z to the 5th. That is our answer. Okay. What I wanted to, oh yes, Sierra.
So when you found G from
Uh-huh.
the exponent, and so you did like the regular exponent rule with the stuff on the inside,
Yep.
and then just by the inside.
Multiplied by the inside derivative. So derivative of the outside evaluated the inside times the derivative of the inside. This is what it is. It's derivative of the outside times the derivative of the inside in practice. So let's do that again. And I promise you, the more you practice it, the more we do it today, the more it starts to stick. So we'll do several of them together, and then we're going to spend a good like 20 minutes doing them as a class together, and I'll be stopping by to help you out if you get stumped, okay? So with this one, this is going to be a quotient rule. So This is our F. This is our G. So F is sine to the fourth of X, which preferably would be written as sine of X to the fourth. That's the thing that many students forget. Sine to the fourth X, that's sine of X raised to the fourth power. So that's a composition. The inside function is sine, the outside is the fourth power. So let's use Leibniz notation here. So y is u to the fourth. U is sine of X. I should use a different color. Use purple. Y is u to the fourth. U is sine of X. So dy du is 4u cubed. Du dx is cosine of X. So remember, the derivative of sine is cosine. The derivative of cosine is negative sine, so on and so forth. So f prime is therefore 4 sine cubed of X times cosine of X. So I think I heard someone say cosine. Was it? Yeah, I made that mistake all the time when I was starting this out. So remember, it's not the derivative of the outside evaluate the derivative. It's just the derivative evaluated at the original function. So it's going to be 4 sine cubed, and 4u cubed. U is sine of X times cosine of X, the derivative of u. And then G is nice and neat. X cubed minus 8, so G prime is 3x squared. So putting that all together, dy dx is going to equal f prime g plus, minus g prime f all over g squared. So f prime g, so 4 sine cubed of x cosine of x times g x cubed minus 8 minus g prime, 3x squared, times f, which is sine the fourth of x, all over g squared, which is x cubed minus 8 squared. And that is our answer.
I feel like we could have got to the bottom part way faster.
Without doing the
Yeah, because when you separate it, all that stuff, I feel like it's harder to do it like that than it is to just go like, okay, what's the outside? It would be 4 sine and then over.
that is the way we're going to do it from now on. That is the faster way. So let's do it. Let's do it the fast way now. The way without having to write the Y's, the U's, the F's, and the G's. Yes, Luca.
I'm still a bit lost.
Okay.
You were plugging them in the bound to like get the whole bottom portion. Like the dy dx equals and then.
Okay. So remember, that's going to be the quotient rule. So f prime g minus g prime f all over g squared.
Where are you exactly plugging in the y and the u?
So that
Oh,
is going for here. So this f prime, this baby f prime, is the dy du times du dx.
Oh,
Is that okay?
okay, now I get it, yeah.
Okay. All right. And believe me, it's okay to be lost right now. The more we do them, the better it gets. The more we start doing it. And let's now try and do it without having to do the Leibniz notation or the composition at the same time. Let's try and do it all in one step. Okay. Previous one. All right. So this one I deliberately chose to remind us of the fact that sine of square root t is not the same thing as square root of sine t. So let's first off rewrite this. as sine of t to the 1/2 plus the quantity sine of t raised to the 1/2. Now, those are both two different compositions. We're going to do two chain rules separated by addition. So we just need to find the derivatives of both separately. So for sine of t to the 1/2, the ddx of that, of sine of t to the 1/2. So now we're going to do it the fast way, the way that you ideally want to get to. So outside function is what? Sine. What's the derivative of sine? Cosine. So this is going to be cosine of t to the 1/2 times the derivative of the inside. The inside is 1/2 or t to the 1/2. So the derivative of that, 1/2 t to the t to the negative 1/2. Faster? A little bit easier. So derivative of the outside, cosine, evaluated the inside, t to the 1/2, times the derivative of the inside, 1/2 t to the negative 1/2. For sine of t raised to the 1/2. Why did I say ddx? ddt.
If we did that on system.
I would. But you see, I count myself. See, I'm reviewing my work. That's what you always want to do, review to work. Oopsies. So, ddt of sine of t the 1/2. What is the outside function? The 1/2. So it's going to be 1/2 sine t to the negative 1/2 times the derivative of sine of t, which is cosine of t. So f prime of t is therefore the derivative of the first part, which was cosine of t, cosine of t to the 1/2. Write that better. Times 1/2 t to the negative 1/2 plus 1/2 sine of t to the negative 1/2 times cosine of t. Now, if you felt comfortable doing that all in one step instead of splitting up into blue and red like I did, you're more than welcome to do so. All right. Part B. Yes. We didn't use the product rule. This was the derivative of the first piece. This was the derivative of the second piece. They're split apart by addition, so we can just take the derivatives of each separately. Very, very good question. Very good question. So yeah, we did not do the product rule here. We only did two chain rules, two separate chain rules, because those two functions were split apart by addition. And what we know about derivatives is that you can just take the derivative of one piece plus the derivative of the second piece. So if they're split apart by addition, you don't need to find any product rule quotient rule between the two of them, that is. You might need to do a product rule quotient rule on each piece, but either way. Now this one right here is a double chain rule. This is a double chain rule. And just as an aside, because so I don't like to use MyLab and stuff like that, especially for calculus, because there becomes places where it is so hard to write the formula without making a little tiny, not an algebra mistake, but rather a typo. And then it marks you the whole thing wrong, and then you have to do the problem over again, and then you get it wrong, and it says now you got to try a new problem. The reason why I say that is because when I was taking this course, and I've put it on the examples, where is it? This one right here. That is a chain rule within a chain rule within a chain rule within a chain rule. and I had to write the answer. I had to write the answer in my lab, and it was the worst thing ever. It was like everyone got that problem wrong. When I became a tutor at UW, that problem always came up, and I would just sometimes I just give students the answer because I was sick of writing it. I would just like say, give me the computer, give me the computer. Let me type it in. You suck with the computer. Let me do it.
What I hate with computers, whenever I would have to type in an answer, is if I put a single space in it.
You're gonna have to write. Do you have a question? Oh, you're just stretching. Good, good. It's good to stretch. Stretch. Don't be like Phil. I haven't stretched a lot, and now my back is in shambles. So H prime of W. So what is the outermost function? Sine. So the derivative would be cosine. Cosine of W squared plus 1. Now we take the derivative of this. That's the inside. Now what's the outer function of that? So negative sine. Negative sine. Yes. The other one, it's very fun, but it's a huge answer. So, but that's not it, right? Because we have to do a quotient, we have to do a chain rule. So that was the derivative of the outer function here. Now the derivative of the inside is 2w times 2w. And that is our answer. Or H prime of W, I'd like to write it a little bit better. I don't like having that minus sign there. I like having my variables first. So negative 2w times cosine of W squared plus 1 times sine of W squared plus 1. Now, granted, I will give you 100% credit if you leave it in the other way. It's just mathematicians prefer to have, the convention is polynomial, like constants, polynomials, then exponentials, then anything else. So logarithms, square roots, cosine, sines, whatever, those always end up at the end. So how I did this, so the 2w goes front, that minus sign goes up front, cosine of W squared there, sine W squared plus 1 is right there. The minus sign got pulled to the very front. But once again, if you want to leave it in the perfect, in the way our math Lord and Savior intended, leave it like that. Ah, excellent question. So cosine of cosine is not cosine squared. So it's a composition, not a squaring. So that's a good point, is that cosine of cosine is not cosine squared. That's a composition. Very good, very good point to bring up is that cosine of cosine is not the same thing as cosine squared. Because and the reason why, cosine squared of x is cosine of x times cosine of x, not cosine of cosine. Does that make sense? And sadly, yeah. Sadly, trig is not that perfect. It's very, very perfect. It's damn near close, but it's not always there. Okay? Exactly right. Yes. But I'm glad you brought that up. That's a good point to mention. All right, k of x. E to the x cubed minus 7x squared plus 2. So what's the outside? E. So k prime is e to the x cubed minus 7x squared plus 2. The derivative of the outside, which just so happens to be itself, evaluated the inside. Now the derivative of the inside. 3x squared minus 14x, or preferably 3x squared minus 14x times e to the x cubed minus 7x squared plus 2. Either way is fine, though. Or that. However you want to write it is fine. I just think it looks prettier, right? Doesn't that look prettier?
It does.
Thank you. Thank you. Finally, a class that gets it. Now, it's okay to still be lost, but I'm hoping that this way is making more sense. It's one of those ones, take a breather each step. So like in that previous one, we did a chain rule of a chain. Take it step by step. And then my recommendation, especially if there's multiple chain rules, do it again. Do it again. Like after you've done it, verify. Because it's very, very easy to start missing some pieces. All right, so how many more do we have? Quite a few. Cool. All right. So I think those ones all will be. Yeah, those are all good ones to do. So what we're going to do is we're going to do this next page all together. And then the next 2 pages after that, I'm going to let you guys have some fun. And I'm going to go around pretending to be a student with you guys. I'm going to be that student who actually doesn't know anything and didn't even bring a pencil. I'm going to be Sullivan. I'm going to be Sully in Monsters University.
I knew you were gonna say that. I have to be like.
It's one of my son's favorite movies right now. So I have watched Monsters University probably about 50 times at this point. Okay, so normally speaking, we don't like, you're not going to need to know the derivative of any base other than e, right? A to the x, I don't expect you to know that one off the top of your head. I would either give you the formula or I wouldn't ask for it at all. But just as a reminder, d dx of a to the x is ln of a times a to the x. So t prime of y, what is the outer function here? Pi to the x. Yeah, that's the outer function. So the derivative of that is ln of pi times pi raised to the cotangent of y. Right, that's the derivative of the outside, evaluated inside. Then the inside function is that cotangent of y. Does anyone remember what that derivative is? Cosecant squared, but it's a cofunction, and all the cofunctions have the negative. So it's times negative cosecant squared of y. Let's check this. It's important. Who wrote it right? Oh, no worries, no worries. But I appreciate you questioning me. I appreciate you questioning me. It's important. It's always important to question what you're learning. ln of pi is our constant. It's a negative ln of pi cosecant squared y times pi to the cotangent of y. Either way is fine though. Teacher stands in front of the class with a lesson plan he can't recall. Students' eyes don't perceive the lies written on every effing wall.
Whoa.
That is Rage Against the Machine. So always question. No. All right. So second one, natural log of 7x to the 5th minus 4 e to the x cosine of x. Okay. So not only do we have a chain quotient or a chain rule, but we have a product rule on the inside. So let's do this. So dy dx or y prime, however you want to write it. What is the outside function? ln. So the derivative of natural log is 1 over x. So, but in this case, that would be 1 over 7x to the 5th minus 4 e to the x cosine of x times the derivative of the inside. And this is where we start to get better with the product rule. So we're going to try and do this without doing the baby s and baby g's. The derivative of the 7x to the 5th, that is by itself. That is by itself. So we just take that one nice and neat. 35x to the 4th. Minus, and actually I'm going to change that parenthesis to a bracket. So your baby f is 4 e to the x, your baby g is cosine of x, right? So f prime, what is, so we can even just like, maybe it might just help you to write like this is f and this is g for a product rule. So baby f prime It's 4e to the x. Times g cosine of x. Plus g prime. What is g prime? Negative sine of x. So instead of plus, we're going to make it a minus sine of x times f, which is 4e to the x. And that is our answer. Fine, fine. Don't make a square. I'm done. I'm done with you. I'm done with your notability. I make squares all the time. Does anybody have any questions on how we got the product rule there? It's okay if you do. Gage.
What's the derivative of 4e to the x, which is 4e to the x?
Yes, exactly. Yeah, the derivative of 4e to the x is just 4e to the x. Trying to trick you. E to the x ends up having very, very pretty derivative.
Yeah.
The best one. It's the only non-zero function that has the derivative be itself. All right. So it would be, like, thank you for asking that. So Sierra said, why are we doing minus sine of x for e to the x? Because the product rule says plus g prime f, right? Remember, the derivative of cosine is negative sine. So I just changed the plus to a minus right from the start. Is that okay? You could leave it. This is no, like, this is also the same as plus negative sine of x times 4e to the x. Both are valid. Really starting to test our algebra skills, right? Starting to bust those bad boys out. All right. This one, C, e to the cosine of x cubed. That is an of. So that's two chain rules. E of cosine of x cubed. So there's going to be two chain rules there. So g prime. Outermost function. E. So the derivative of e is itself e to the cosine of x cubed times the derivative of the inside. Derivative, like, of that function, what's the outer function for of this? Negative sine of x cubed times the derivative of the inside, 3x squared. So all right. Any questions on that? And you can write it, though, preferably as following the conventions, or just because it's bugging me, or negative 3x squared e to the cosine of x cubed times sine of x cubed. Doesn't that look more pretty?
Yeah.
Thank you for agreeing with me. You get marked down if you didn't agree. So, how are we feeling? Are we feeling a little better now that we've done several practice problems? Okay, so what time is it? It's 10:37. So we're gonna go ahead. I want you guys, okay. I want to mention something about these A, B, and C. Do you guys remember the rules of logarithms? So you can do this. Part A, you could do it the long way. You could do it by saying, okay, well, outer function is natural log, the inner function is sine of t over t squared plus 1, and then do a quotient rule on that. But you could remember, reminder, log base b of m times n is log base b of m plus log base b of n, and then log base b of m divided by n is equal to log base b of m minus log base b of n. And last but not least, log base b of m to the r is r times log base b of m. So you can simplify these. So what's gonna be easier to compute? That derivative as it stands, or writing this as natural log of sine of t minus natural log of t squared plus 1. Much simpler. Because now I don't need to do I just need to do two separate chain rules. First, a chain rule in the first piece minus the chain rule in the second piece. Instead of doing a chain rule that involves a quotient rule. Right? Now that being said, both are valid. Both are valid. You say potato, I say potato. I would want, like, if this was a question on the exam and you did not remember that trick about logarithms and you did it the long way, I'd still give you full credit because it's still mathematically valid. It's just, why not make it easier on yourself, right? All right, I want you guys to find that derivative. I will slowly fill in the details. Yes. Yeah.
Yeah, of course.
Yes, yes, you can do that, and then yeah, and you can yeah, you can cancel that, and then it would. That's why it's on the other side. Okay, we'll go about it. Okay.
So would it be subtracting?
And you guys can ask questions to me while we're going through this. I'm happy to help. And it is okay to ask for help, just letting you know. Okay. Oh, yeah, I do. All right. Oh, like, let me pass those out.
If you were to do this as this is not, like, this is not, this is you. Yeah, again. Not yes. So what is, so the, 1 over 5 times 1 over.
I'll be right there, Paul.
This was just right. I would just wish. Because sometimes it can be wrong. Because for the school, it's like a child. It's where, yeah, figure something out. You explain what you're doing. Because here it's the speed.
So you could get cosine of t over sine t minus 2t over t squared plus 1, or cotangent, because cosine over sine is cotangent, minus 2t over t squared plus 1. Any questions on that? So, ln of sine of t, outer function is natural log. So 1 over the derivative, 1 over the inside, that's the derivative of natural log, times the derivative of the inside, sine derivative is cosine. Similarly for natural log of t squared minus 1.
It's multiple.
Second one, just as a note, so I don't expect you to know this offhand, ddx of log base b of x is 1 over ln of b times 1 over x. So in this case, one thing we should do first is convert this to the proper form so that we don't need to do a chain rule of a chain rule. Not saying that's not important, but you don't have to. So this is, oops, color, log base 5 of q cubed minus 4 to the 1/2. So that's going to be, by the power rule of logarithms, you can bring down the exponent and get 1/2 log base 5 of q cubed minus 4. That's a little Easter egg for me. I love writing q cubed. Not I love writing a q cubed. I love saying q cubed. It's very fun to say. Just go ahead and say it in your mind or say it aloud under your breath. Q cubed. Just feels right. So c prime of q. Now, the reason why, by the way, I'm doing this, I did this whole page, is to prep us for something we're going to be doing a little bit later when we get to 2.5, which has to do with what we call logarithmic differentiation. You'll see it in action. All right. And on this one, instead of doing a chain rule within a chain rule with a quotient rule, let's make it simpler on ourselves and write this as 1/2 natural log of 2e to the 3x plus 1 minus 1/2 natural log of 7x minus 2. Because that square root is to the 1/2 power, bring that out front. And then you split apart the division into subtraction. That's where and then the 1/2 gets distributed into both. So that's why we've got 1/2 natural log of 2e to the 3x plus 1 minus 1/2 ln of 7x minus 2. Find that derivative. I'll slowly fill in the details. Get the answer up here if you'd like to check your work. Kind of live, I was saying that I'll slow it in these. I felt it quite quickly. I just like dealing with logarithms. Logarithms are probably one of my favorite concepts in mathematics. Yes. Yeah. Why did I multiply by 3? Chain rule. So that's a very, very common one. E to the 3x, that is a chain rule. The outside function is e to the 3x, the inside is 3x. So derivative outside, e to the 3x times the derivative of 3x would be 3. Thank you for asking. It's a very, very important one. Those ones happen all the time and they always trip people up. I don't want them to trip you up. Oh, I forgot to mention this, by the way, at the beginning, just because I'm thinking about it because of something that happened during office hours. These things are not like these are things that I like. This whole these guided lecture notes. These are things that I wrote, and they're not perfect. This is I think my 6th run time of it, maybe 7th. I can't remember. But it's not infallible. It's not perfect. So if you guys have any suggestions or any critiques, I'm always open to hear them. I want these things to be the best thing that they can be. So if you have any suggestions of things to add or get rid of or things to change, please let me know. And I will take those considerations under advisement. Just letting you know, it's not like I do not take any offense to that. I want these things to be the best things for you. So I love to hear comments on it, especially when it comes to the evaluations, of course. But anyways, so 1/2 ln of 2e to the 3x plus 1. Natural log is the outside function, so 1 over x, but in this case, that would be the 2e to the 3x plus 1 times the derivative of that, which we just talked about, it does require a chain rule. And then the second one, 1 over 7x minus 2 times the derivative of 7x minus 2, which would just be 7. And then just doing a little simplification, canceling out the 2, you get your answer, which is that. Though, once again, I would accept on a quiz or an exam the unsimplified version. Just ideally try and simplify it when you can. All right. So these bad boys, A and B, I would like you guys to do these by yourselves. I'm going to come around and help whenever need be. You guys, the second, feel free to talk to your neighbors. They won't bite. If you don't have any neighbors, imagine you have a friend. What I do on a regular basis.
So, right, we don't have this. Right. This one. So then it would be. Those will be multiplied by? So it'll be like. Yeah. Because since you're getting it, that's. Right, right.
Okay.
It's okay.
You'd like to ask questions?
You don't have to get rid of all of them. Okay. X plus 2x minus 3 minus 7 minus, and then Right, because now it's the G. You know, it's where- Right, right. Two. They got weight. Well, now the ball was these. No. Wait. No.
Oh, it's mine.
Wait, hold on.
This is, yeah, we made no mistake.
That is mine. I think that's.
Why did you write it like that? No. This is where I, it's supposed to walk for me. So it's explanation.
He wrote it up there as a final part, or as times give a minus. D of prime.
No, it's N prime, no, N prime, G, and then G. Not that I have one back.
Yeah, that's what I did.
How do you think about it? It's more, I mean, I think people.
No, I never thought about it. Right, yo.
Why did you come up with that?
That's smart.
You come up with that? Says, I mean, I give this. Yeah. Whatever it is, 6 hour. We got that on us. So this is how it is. Know that, no, it's just right. Hands the outside element of X is the side, and then this is the side. So how you.
That, and then it's deep.
Oh. Okay.
Because chain government needs assumptions. It's not, it's not. But I think that F line is. So.
You think that.
Where are you at? There you are.
Oh,
Why is it separate?
It's,
It's a second school.
do, research, so you have a computer. Do you remember, what you do for content?
One.
Where you can constantly do like, yes, what is that one? It's you're doing short for the whole audience. I think that's what it is. If you're constant.
Look at that. Wow. People hands in.
Yeah.
It's a.
The whole different.
It's great. I'm trying to do part 10. And. There's. This is the that's why.
Yep.
It's the.
Perfect. And there, that's why, and then you're gonna be.
And about. This is a outside. I'll send this again. The inside. Right now, outside inside of the other cheap. This is a question. So what does that say to you? This is.
I think it's all next time, but. One can figure out the it's and look at all that.
The answer up for part A, if you'd like to check your work, and we'll start working on part B.
Why does it, why does it feel like everybody looks at it? Every student. Look. You're right, but like. It's what?
We're giving Gates on he's ready to have this time to smart.
That she. This kid, he's also that out there, so. Don't wait and. Okay. So it's gonna be a product. So now we gotta do there's this piece here. It'd be like this piece. This is the first piece. That's just saying.
Oh, no, but now I think it's.
I'll come back in a second.
And front.
No, and front.
Yeah, that's fine.
So that's Howard, so you like, I'm not right. Yeah. Is A. So if this is actually 7, then and then 7. Yeah, so then there's something like it's oh, I mean, he's better than I guess it's not even it's the revision of the outline. We might be inside. That should be not a position. Because remember, it was they, the derivative of the outside on the inside times the derivative of the final. And that would get you.
That makes sense.
Right there.
So.
So then. Clarify.
Yes.
The derivative of or okay. Remember, it's. We did cross F that's to. You're going to stand down and move that quad. So you gotta use the quad.
I knew it.
You don't. You can bring it up into my.
That's where you do the line here.
So yeah, you're gonna take, the derivative of that first piece, is gonna be e to the 4x squared times the derivative of 4x. It's not 4x squared. Oh my gosh, it's next.
Earlier.
Got it?
No, I know.
So. So right here. Yes. E to the 4x squared. It's going to be change conversations out of the right here, and the derivative of is itself. E to the 4x squared times the derivative of 4x squared.
Alright, guys, I'm sorry.
I'm sorry if I didn't get to help you trying to do it. I'm gonna write the answer to this one right here. All right, that should be your answer for that one. All right. And I just jumbled things around, just make sure that the jumbling matches up with your jumbling, remembering that multiplication is commutative. So A times B is the same thing as B times A, so I've just jumbled them around to make them look pretty. So F prime, e to the 4x squared. Remember, that's not a power rule because that's not x to the number. X to the number is the only time you can use the power rule. Not x to the x, not e to the x, not anything like that, only x to a number. So x to the pi, power rule. X to the square root 2, power rule. X to the x, not power rule. So that's going to be e to the 4x squared times 8x. G prime. Outer function is tangent, so secant squared of ln of x times the derivative of the inside function, which is 1 over x. So f prime g plus g prime f. All right, guys. And unfortunately, I think we're going to have to skip taking a break today because we only got 10 minutes. I'm going to go ahead and I'm going to skip this problem. I'm going to make a video later today to show you how to do this problem, and I'll post it to our Canvas page. and send you a link to the video as well. Okay? So please do that one over the weekend. Please watch that video when I post it. But honestly, I'd encourage you to try it yourself. It's a really fun problem. If you want inspiration before, look at page 66. So look at page 66. For inspiration. All right. And so with that in mind, then we're going to go over to 2.5 and start that up. All right. Because we were supposed to start and finish 2.5 today. And then the same thing with this one here. We're going to do this one. I'll do both of these examples for you guys to watch a little later. Okay. Implicit differentiation. So first off, let's talk about English. Let's talk about English verbiage. So explicit versus implicit. To say something explicitly is to spell it out, right? To say exactly what it is. So up until this point, we've been doing what we call explicit formulas. It's always f of x equals blah, or g of x equals blah, or y equals blah. That's an explicit formula. It defines y purely in terms of x. Implicit kind of means implied. There's an implied function here that we don't have written out. So as we've seen with previous parts, there is to be interpreted as the slope of the tangent line of a given value of x. Consider the circle, though. That's not a function, right? It fails the vertical line test. So x squared plus y squared equals 25. The graph is a circle centered at the origin. And it doesn't represent a function, but we can still draw lines tangent to the curve, right? We can still draw a tangent line here. We can draw a vertical tangent line here. It's gonna drive me nuts if I don't. There we go. And you could even draw one right here. You can draw a bunch of different tangent lines to it. So the question is, how do we do that? We should be able to do it with calculus. Now, there's a way to do it without calculus, which is really fun. That takes way too long. But how would we find the equation of a line tangent to the point 3, -4 on this graph? So one option, the way that we probably would have to do it, would be by solving for y. So if you solve for y in x squared plus y squared equals 25, you get y squared equals 25 minus x squared, and we take the square root of both sides. And John Doe student just then says y equals the square root of 25 minus x squared. Why is John Doe student wrong? Why is John Doe student wrong?
Because he's not taking a class.
True, he's not taking the class, I'm not here. More importantly, when you take the square root of both sides, what happens? You take the square root of both sides, but there's a plus or minus. Remember, when you take the square root of both sides of an equation, you have to do the plus or minus. Because in the real world, we probably don't need to worry about the minus. If you're taking the square root in the real world, you very rarely have the negative answer. But in math, when we're dealing with these things theoretically as objects, there are two options. So there's a plus or minus there, which means, and that makes sense. You can't write the equation of a circle as an explicit formula. There's no way, because it's not a function. So there's no way that there shouldn't be a way to write it as y equals blah. In fact, we have two different options. We have either y would equal positive square root 25 minus x squared or negative square root 25 minus x squared. Now, 3, -4 is in the fourth quadrant, right? Is in quadrant 4. So we'll use the negative version of the function. The positive version gives the upper half of the arc, and we can even write that down. So this right here, this positive piece, that is y equals the positive square root of 25 minus x squared. And then the bottom half is given by the equation y equals negative square root of 25 minus x squared. And the reason for that is that tacking on that negative in front of the minus sign will make all your y values negative. That's why it gives you the bottom half. So because we're in quadrant 4, we're going to use the bottom function. We're going to use the minus version. So we'll use the function y equals negative square root of 25 minus x squared, or preferably, when we're going to be taking derivatives, negative the quantity 25 minus x squared to the 1/2. So, taking the derivative of that, y prime or dy dx, however you want to write it, would be derivative of the outside, which is that 1/2 power. So, negative 1/2 times 25 minus x squared to the negative 1/2 times negative 2x. Right? Preferably, I'd like to write this just because it looks prettier, but you can keep it in this format because we were allowed calculators in this class, so you can just plug in numbers nicely. But this will be the negative 2 and the negative 1/2 cancel, and we just have x over the square root of 25 minus x squared. Because it's 25 minus x squared to the negative 1/2, so that puts it in the denominator. But you can leave it as is. You can totally leave it as is, and we'd be all great. Now, we wanted to find the equation of the tangent line at 3, -4. We already have the point, so all we need to do is find the slope, right, which is given by plugging in the x value into the function, right? So m tan would equal y prime evaluated at x equals 3, which would be 3 over the square root of 25 minus 9, which is 3/4. Yeah, because 25 minus 9 is 16, square root of that is 4. 3/4, that's our slope. We have our point. So our line is y minus -4. So y plus 4 equals 3/4 times x minus 3. And I guarantee you, if you graph that line next to the circle, you will get a tangent line there. That's great and all, but x squared plus 20 of y squared plus 25 is a very, very nice implicit function. There's only 2 pieces to it, but there are far more awful equations. For example, x squared plus ln y minus e to the x sine y equals the square root of x plus y to the 7th. How would you solve that for y? Try. I can't. There actually isn't a way. I don't remember off the top of my head what that function looks like. That's a pretty hard one to memorize. But I would bet money that that function is loop-de-loop everywhere. So there's like 80 million pieces to it. So trying to find the derivative of that by finding an explicit formula is just off the table. It's not in the cards. So instead, what we're going to do is assume that y is a function of x. We're going to implicitly assume that what if it was able to be found, but it's just too much algebra to find by itself. In other words, functions exist in every equation except that we cannot see an explicit formula of y equals x stuff. So we're going to write it as y of x or f of x or whatever it is. Further, the slopes of the tangent lines can be found by finding the derivative of that y prime equals dy dx. So the process of doing this is going to be called implicit differentiation. So how do we do implicit differentiation? The first thing is to differentiate the entire equation, remembering that y is a function of x, and as such will require the chain rule. Like it might and might require the chain rule. So in this one, y cubed plus y squared minus x squared equals 5y minus 4. There's not an easy way to solve for y in this. Technically speaking, this is a cubic. If you're looking in terms of y, you can there's a cubic. And there is, just in case you did not know, there's a quadratic formula. There is also a cubic formula. It is very, very nasty, but if you ever want to know, feel free to ask. but differentiate the entire equation. So what we do, and this is important, we write d dx, and actually I'm going to change this. So I'm going to say differentiate with respect to x. So d dx of the left-hand side equals d dx of the right-hand side. And let's fill it in with the actual stuff that it is. So y cubed plus y squared minus x squared equals d dx of 5y minus 4. All right, now keep in mind, that is the derivative with respect to x, not with respect to y. So the answer is not going to be 3y squared. It's going to be 3y squared times dy dx. Now you could write y prime, that's fine, but I encourage you to not do that purely because the y prime starts to look like a y to the first power, and then you just can get yourself in a whole big mess. So why is it 3y squared times dy dx? I'm going to put an asterisk here. So d dx of y cubed is the same thing as d dx of y of x cubed. Remember, we're thinking of y as a function of x. We're differentiating with respect to x. So d dx of y cubed is taking the derivative of a function to the third power, a function that depends upon x raised to the third power. So it's a chain rule. Outer function is to the third power, inner function is y to the x. So chain rule.
Found this on the web.
No, you did not. So it's going to be 3 times y of x quantity squared times y prime of x, or more aptly, 3y squared times dy dx. That's why it is that way. So that makes sense. Please ask questions if you have them. So in a similar vein, the derivative of y squared. Y is a function of x. So that's y of x quantity squared. We're gonna finish this step and then we'll come back on Monday with the rest of it. But plus 2y times dy dx. Because y is a function of x. So that's y of x squared. Outside function is the squared power. So 2y of x to the first power times the derivative of y of x, which is y prime or dy dx. And then you're taking the derivative of x squared with respect to x. So that is, x is a function of itself. So like this one is just 2x. Then the derivative of 5y would be 5y prime. So 5 dy dx minus 0. Because the derivative of a constant is 0. So that's the first step. The next step is going to be isolating the y's, but we'll do that next time. I don't want to keep you guys later than I have to. We'll pick up next time with this. If you have any questions, please feel free to email me. Otherwise, you guys have a wonderful weekend. And I will see you guys on Monday, okay? Go have some fun. Go do some fun differentiation problems with your bros and your bras. All right, guys, have a good one.